Hey, algebra class. I'm sure you're excited about the first ever video you get to watch of many, many wonderful, wonderful algebra videos. So this is the review for Algebra 1. So when you come to the video, you should have already hopefully checked your work, done the extra credit, checked it, and now you either have things that you need some clarity on, things that you need to go over. Yes, you can go forward to find the videos or the parts of the video with the questions you have. At first, I guess I would recommend watching the whole thing until you make sure that your test scores are where you want them to be, and then maybe slowly wean down to just the questions that you got wrong. But because I sometimes will throw in extra things along the way. So, anywho, let's get going. So, all right. Evaluate. Evaluate means what? Find out the answer. Each expression, notice there's no equal signs because it's an expression. For Q equals 5, P is 11, and R is 15. So we're just going to substitute those values in, and you be very careful you don't put the wrong value in. That's just such a bummer. Okay, so R is 15 minus Q, 10. Q, and what's the operation? Multiplication. Q is 5 times P, which is 11, 55. R divided by Q. R is 15 divided by Q, which is 5, and that is 3. So far, not too hard, folks. R is 15 divided by P, which is 11. So you can actually leave that. I don't expect you to actually divide that out, or you can put it in mixed form, I mean. 1 4/11. Either is completely fine. So you don't have to go any further than that. P minus Q. P is 11 minus the Q, which is 5, and my answer is 6. Give 2 ways to write this in words. So of course, my favorite is using sum, so you get familiar. The sum of y and 5, that would be 1. You could do y plus 5, the sum of 5 and y, 5, either of those are fine. All right, Sammy Joe walks 7 miles each week. Write, I always underline my verbs so that I don't miss part of the question. Write an expression for the number of miles he walks in y weeks. Find the number of miles he walks in 5 weeks. Okay, so he walks 7 miles each week. Write an expression for the number of miles he walks in y weeks. Okay, so that would be 7y. I've done that one. Now find the number of miles if he walks 5 weeks. So my y is 5. 7 times 5 is 35, and I need a unit, which is miles. All right, add or subtract, different signs. So we've got a -3 and a +10. They're different. Who wins? The positives win. There's more of them on the team. How many more? 7. One moment, please. All right, now the next thing we have is -4 minus 6. Remember, subtracting is the same as adding the opposite. So I have plus -6. Now, same team or different teams? They're the same. They're both negative, so we just put them together. Negatives carry the game at -10. Now we got 2 plus a -7. Same team or different teams? Different. Who wins? The negatives win. They have more. How many more? They have 5 more. And lastly, we got 12 minus a -2. Subtracting is the same as adding the opposite. So it becomes a 12 plus 2, ultimately, which is 14. All right, it's recorded. Let me get this on the screen better. It's recorded that the low temperature in Prospect, Alaska is -80 degrees Fahrenheit. Holy cowboy. The lowest temp in Camp Clark, Nebraska is negative 47 degrees. How much greater is the low temperature in Nebraska than the low temperature in Alaska? Nebraska, Alaska. Okay. So we are basically going to subtract them and find out the difference. But you got to be careful which one is the bigger number. Ding, ding. So negative 47 is actually warmer, right, than negative 80? Then we're going to subtract the other temperature because we're looking for the difference of the two. Now, subtracting is the same as adding the opposite. So we end up with a fight again between the positives and the negatives. The positives win. How many more? If you do a little subtraction over here, if you don't see it, you will see that it's 33 degrees. Not temperature. Remember, we're looking for the how much greater is it. So we're looking for a difference. All right. Label the 4 quadrants. Label them properly, please. Not like I did that one day. Okay. 1 is always up here. 2. 3 going counterclockwise, and 4. All right. Time for a word from our sponsor. Hello. Are you looking for a healthy drink? One that is good for you but also tastes good? Why not try Zevia? Zevia has 0 sugar and doesn't have garbage. Let's look and see. There it is. Does everybody see it? Stevia leaf. Natural leaf. Stevia leaf. This gives it a nice sweet taste while keeping you good and healthy. All right, back to our algebra after that short commercial break. And we want to be able to see it. There we go. Multiply or divide if possible. Multiplying 2 numbers. They are both negative numbers. So we get a positive and we just simply do, this is not subtraction, people. Do not subtract those, please. There's a multiplication in there. So this is a positive 24. Now, we went through a whole day of refreshing fraction work. Dividing fractions. Remember? Keep, change, flip. We keep the first one. We change from a division to multiplication, and we flip or take the reciprocal of the second one. Now we can cross cancel. 1 and 2. Multiply across the top. Negative 1 times 2 is a negative 2. 1 times 1 is 1 on the bottom. Do I need to write that? No. All right, go to the next one. Negative, or 21 divided by a negative 7. Is that going to be positive or negative? That will be a negative. Good. And then you simply divide. 21 divided by 7 is 3. 0 divided by negative 4. What is that? 0 divided by negative 4. It also can be written like that. And it is 0. When does the calculator explode before your very eyes? When you put a 0 in the bottom. Can't do that. Okay? All right, next, simplify. Simplify means to make it look simpler. So 2 to the 4th is not 8, by the way. It is 2 times 2 times 2 and times 2. And as long as you do those properly, you'll get the right answer. So 2 times 2 is 4, times 2, 8, times 2, 16. So make sure you go the right number. And this is raised to the 3rd. So the question is, do I include the negative the negative when I multiply or not? And the answer is yes, because it is in these parentheses, and everything in that parenthesis is raised to the 3rd power. So I have negative 2/3 times negative 2/3 times negative 2/3. My answer is going to be a negative 2 times 2 is 4, times 2 is 8, over 3 times 3 is 9, times 3 is 27. 3 to the third. 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Negative 4 to the second. Is the negative involved? No, there's no parenthesis like this. So that means this negative is just the little guy hanging out front. He just stays. You do nothing with him. Then we multiply the 4 times the 4. And what is that? 16. So I have a negative, because it's hanging out, 16. All right, write all the classifications that apply to each of the real numbers. So let me grab my other sheet here and let's see. Hopefully you guys can write these down by memory by now. At the very top in the big cloud of all the numbers that you know at this point in your math career, you have the reals. And the reals break down into two other subcategories. What are they? Irrational and rational. Irrational are things like square root of 29, because it doesn't come out even, or pi. Rational can be written as a fraction. 8 over 9. Okay. Okay, I was totally blanked out for a second. All right. Now we break that down into decimals. So we have repeating decimals. And we have what? Terminating decimals. You have this in your notes. You know that. Study it. So a repeating decimal would be like a third because it's 0.3 repeating. And a terminating decimal would be like 1.5 because it stops. Now, the terminating keeps going down into what? Integers. And what are integers? Negatives, 0, and positives going forever in both directions. And under integers, we have whole numbers. And wholes are part of this. It starts with the 0 and goes on. Doesn't have the negatives. And under that, the last one is the natural, or there's another name, counting numbers. And that one is almost the same as this, minus one number, 0. Because when we count, we start with 1, 1, 2, 3, etc. So now back to the problem at hand. Classify. 18. How far down can you see 18? It would be in here. So I'm going to write for an answer here. Let's see if I can get this all on here. Whoa, oh wow, okay. I'm going to write natural numbers. And then I got to look straight up because I'm going to put everything else above it. Whole numbers. It's also a integer. An integer, not a integer. It's also a terminating decimal. It's also a rational. I keep moving up. And even though it says it's a real right here, I still want to add that in there just because it's a good reminder. Okay, so you put everything. Now square root of 5. Where's square root of 5 on here? Beep, beep, beep. So all you have to write is irrational and reals. Negative 17. How far down do we find the negative 17? Where would that fall in? Boom. Integers. So I'm going to write integers and then everything above it. Terminating decimal. And rational. And real. And lastly, we have 1/8. 1/8. Is 1/8 a counting number? No. Whole? No. Integer? No. terminating decimal or repeating decimal? Jeez. I don't know. Let's see. 1 divided by 8. Put your decimal in, add a 0. 1, subtract. 8 goes into 20, 2, 16. Bring down another 0. 8. Oh, look at that. 0.125. And what happens? 0. So what does that mean when it stops? It means it's a terminating decimal. So my answer is going to be terminating decimal, and you can abbreviate it if you'd like. And irrational, not irrational, and real. All right, well, I hope that helped you a little bit. I have to go stir the ground turkey that I am cooking. So one moment, please. All right, I'm back. Let's change colors. Kind of sick of the blue. Okay. Evaluate each expression for the given value of x. Okay, so they give you the x. You got to plug it in and do your order of operations right. Honestly, that's it. So let's do it. -2 minus 6 over the x raised to the second power. -2 minus 6, remember when you have a fraction bar, you got to do the top and then the bottom and then you divide. So it's -8 because subtracting is the same as adding the opposite. So I've got two negatives, I combine them, I get a -8 over 2 times 2 is 4. And yes, you can do that first. It didn't matter in this situation because I was doing both of those, but PEMDAS would say do powers first. But we're doing them, so it wouldn't matter on this one particularly. But it is a -2 when you're done. Next one, x is 11. So go in here and rewrite it. Don't take shortcuts. That's how the little mistakes get missed, lost, etc. And they do add up on the test. Order of operations, PEMDAS. So what do we do first? Parentheses. So we're going to go in the parentheses and see if there's anything in there to do, and there is. 11 minus 1 is what? 10. Okay, you next do exponents. Okay, be careful. There are people that would say 80 and then square it. No, the only thing being squared is a 10. 10 to the second power is what? 100. So I have 800 for an answer. And 28. X is 7. So let's go in there. We got 22 plus -2 times 19 minus 7. All right, we got a bunch of things here. So we got a bracket and we have a parenthesis. So go on the innermost parenthesis first. We're going to do that first. I'm just rewriting. And then I'm going to put what the answer is, which is 12, inside the parenthesis, like that. So again, there's nothing more to do in the parenthesis, so I don't have to worry about that parenthesis anymore. But it does separate it from this and reminds me that it is what operation? It's multiplication. Okay, so now I'm going to this bracket and working. So I've got -2 times 12, which is a -24. Now we got two numbers being added. One's positive, one's negative. And which team wins? These guys, the negatives, by how many? 2, because they have 2 more. All right. Are the two following phrases the same? And what are the two expressions? Okay, so here's one and here's one. So let's look at them. Whoa. 4 times the difference of a number and 5. The difference of 4 times a number and 5. The answer is no. These are not the same. Because here it's saying 4 times something. But what's it multiplying it by? It's multiplying 4 times the difference of something. It didn't say 4 times a number. It said 4 times a difference. So when you see 4 times a difference, 4 times a sum, 4 times a product, 4 times a quotient, it's implying a parenthesis there because it's about to tell you what's in the parenthesis. 4 times the difference of what? a number and 5. It gives you the two things. Now, what you say, well, what am I going to put for a number? Well, pick a variable. It doesn't matter. I'm going to pick x because I like x. And 5, difference. Now, let's see what this one says. This one says the difference of, so now it's starting with a difference. And it's about to tell you the two different things. See, the two different things here when it went in this difference was a number and 5. So here's my and. That's my separator of the two. So the difference of what? 4 times a number and 5. 4 times a number. Again, I'll just call it x. 4 times a number and 5. These are different. You may say, why? Well, if you multiply and get rid of these parentheses and you distribute, which is how you would what you would need to do to properly get rid of the parentheses, you are going to get 4 times x, subtracting is the same as adding the opposite, plus 4 times a negative 5, which is negative 20. That is different. Okay? So your answer, though, you're saying, what would my answer be? It would be that original thing. This and this written here. Okay? So be very careful. 4 times the difference. The difference of this and this. Okay, good work. We're getting there, folks. We're almost done. All right, so when you are simplifying expressions, it means to make them simpler, right? But first you have to look and see how many terms you have. So when I look at this, I see how many terms? 3. We've got a 5 and a 4th, we've got a 7, and we've got a 2 and 3/4. Remember, terms are things added or subtracted together. Okay? So when I look in here, I see 3 numbers. Great. That means they're like terms. I can just put them together. But I also know when I'm adding a bunch of terms, I can just add them in any order. So I'm going to look at these two because I think those fractions are going to come together quite nice. Because I see 5 plus 2 and I get 7. And then what's a 4th and 3/4? It's 4/4, which is another whole, isn't it? So instead of 7, now I have 8. And I'm just going to go up here in case you didn't see that. 5 and 1/4 plus 2 and 3/4 is equal to 7 and 4/4, which is 8. Okay. Then I can't forget this in there, and my answer is 15. Okay, what if I said, okay, that's great. We're going to follow the same thing I just said. We're going to see how many terms are in the next one. Well, that's not really fair because we got these parentheses. So you got to get rid of the parentheses first. The exact same way I just showed you with this. When we distributed, we're going to do the same thing here. We're going to distribute. Do our little spider legs. And it's already plus in there, so I don't have to change that. So negative 2 times x is a negative 2x. Negative 2, and then plus. Sorry, I put the plus in there. Negative 2 times 5 is a negative 10. Plus 4x. Add that last term on there. So now, how many terms do we have? We've got 1, 2, and 3. Are any of them like terms? And remember, like terms mean they have exactly the same. If I have an x, y, and an x, those are not like terms. If I add a y, now they're like terms. But if I put a little 2 here, now they're not like terms. Okay? Or if I add a 2 here, now they are. They have to have the exact same combination of letters, variables, and their powers. So when I look in here, I can't put this with this. That has an x, that does not. But I can put these two together because they both have exactly x to the first power. And I've got a negative 2 of them and a positive 4. So I simply add the numbers in the front. And I will get a positive 2x. Okay? The x stays. You don't raise it to the second power. It's like saying if I have 2x plus 3x, I get 5x. Okay, if I have 2 apples plus 3 apples, I get 5 apples. I don't get 5 apples to the second power. Okay, we're adding. We're just combining. That wasn't related to this problem, but. So I have 2x, and then don't forget the middle term here, plus a negative 10. That is the correct answer. Or if you write it like this, that is also a correct answer. Okay, because adding the opposite is subtracting. They're the same. Go to the next one. How many terms? 1, 2, 3. Are any of them like terms? Yes. This one is. Oops, we have a subtraction, so let's go in there and change that. Subtracting is the same as adding the opposite. That is the same, and so is that. So I can combine those. And right away you should say, but there's no number, and you know the answer to that. Negative x is the same as a negative 1x. So I've got 3x and a negative 1x. That leaves me with 2x. The middle term cannot be combined. I cannot put those together. Typically we want to put the higher power first, but I won't mark it wrong right now. But they're both the same thing, so either way is fine. Okay, no go. Can't put them together. Okay, now graphing. We talked about graphing. We talked about how this is our positive, this is our negative side. This is our positive, this is our negative. Every coordinate is an XY coordinate where you put the x-axis first. Why did I put a y there? Axis. And the y-axis. Second. So graph each point. And when I say graph, that means you got to put that letter with it. So 1, negative 3. So 1, 1, 2, 3. W. Negative 3, 0. 1, 2, 3, and I don't go up or down. There's nowhere to go. That is x. 5, 3. 1, 2, 3, 4, 5, 1, 2, 3. Y. And 0, 2. So 0 in this direction, and negative 2, I'm sorry, down 2. And that is Z. What quadrant is this? Good. First, then we go counterclockwise. Second, third, and fourth. Generate ordered pairs and graph them. Okay, so you're going to set up your XY chart, and I'm going to just write my equation right here so I have it down here. And then here are all the x's I gave you. Negative 1, I gave you half of it. You got to get the other half. Okay, 1 second. I got to go do my turkey again. Okay, so let's finish this up. So we're going to take the negative 2 and put it in for the x. Now, when you put it in, whenever you put a negative number, you always want to substitute it in parentheses, or you're likely going to get mistakes. Here, let me show you. If I don't put a parenthesis, this is what I see. 2, and now I'm going to put my x in. Minus 2 minus 1. That's negative 1. No, it's not. Because what's the operation here? It's multiplication, but instead you subtract it. Okay, and that is simply learning to use the right symbols. There it is. So let's try that again. Y equals 2 parenthesis negative 2 minus 1. Now we have the right symbols in there. So we know that this is multiplication, and 2 times negative 2 times negative 2 is a negative 4. Then we have the minus 1. So the actual answer is a minus 5. Negative 5. Okay? So be very, very careful. Now what happens if we put in a negative 1? Okay, so y equals 2 parenthesis negative 1 minus 1. Again, 2 times negative 1 is a negative 2 minus 1. One moment, please. Okay, sorry. Who liked my ringtone, the harp? Anyway, it's my daughter. She's in California. So, all right. So -2 minus 1, add the opposite. So we have a -2 and a -1, and that is a -3. Then we go on and do the same thing with 0. So y equals 2 times 0 minus 1. 2 times 0 is 0, minus 1 is a -1. Oopsie, move that up. And I'm going to move up here now. Y equals 2 times 1 minus 1. That's 2 minus 1, that's 1. And then finally, y equals, I'm just going to write right over this, 2 times 2 minus 1. That's not working. Y equals 2 times 2 minus 1. That's y equals 4 minus 1, and that is 3. So now we can graph these, okay? So -2, -5. So I start in the middle, right here. -2, -5. -1, -3. -1, -3. 0, -1. So 0 this way, -1. 1, 1. 1, 1. 2, 3. 1, 2, 1, 2, 3. What are you noticing here? That is not centered. Yep, it looks like a line, and you would need to write what you see described there. You don't have to connect them. I'd rather not have you connect them because I gave you specific set points. So those are, it's called a discrete graph, which we haven't talked about, but I actually don't want you to connect them because a continuous graph would be connected. So we are going to stop with that. We did generate our ordered pairs, and we graphed them, and we described. Oh, I forgot to underline that. There were 3 things: generate, graph, describe. All right, folks, there you go. First one, I think that was it. Yep. Okay. Have a great day. Bye-bye.